it away, Brian.
Awesome. Thanks everyone for having me. Thanks Peter for having us and for hosting this. My talk's titled Preparing Flexport's Transmission Web Frontend for Scale. I'm Brian. I'm a senior software engineer at Flexport. That title, I realized, is actually not very good. It's a little wordy. It doesn't really roll off the tongue. It describes very literally what I'm about to talk about, but I wanted to try to make it a little bit more fun. So I was brainstorming titles in my spare time a couple days ago, and I realized that this talk kind of condenses to this. It's a horror story of event subscriptions gone terribly, terribly wrong. We had a map component in one of our products that one of my first tasks when I joined Flexport a couple months ago was to optimize this map component and make it passively renderable with a couple more scale than this map had ever supported before. And it really kind of distilled down to this fact, these event subscribers gone terribly, terribly wrong, and we'll cover some of the things that I found throughout this presentation. So here's the agenda. I'm going to talk a little bit about Flexport and a little bit about what we're up to here in the Chicago office, which focuses exclusively on trucking. Flexport is a company based out of San Francisco, and they've opened an engineering office here in Chicago very recently. And then Houston, we have a scaling problem. I'm going to talk a little bit about root cause analysis and some fixes for some front-end performance bottlenecks from this map component. And then I'll just summarize everything with some takeaways. So I wanted to start with what does Flexport do? Not a lot of folks here in Chicago know about Flexport. And Flexport itself is a freight forwarder. We are a digital freight forwarder. We use technology to our advantage to serve more customers with fewer people doing phone calls and sending emails and all this paper-based stuff behind the scenes. So freight forwarding itself is this really complicated relay race of unstructured data. This is how it's kind of gone in the past. This is what Flexport is really trying to break the mold of. We work, you can think of a freight forwarder as a broker between people who have stuff that they want to ship and people who have space to ship that stuff. So we sit in the middle and we kind of coordinate all the logistics around moving stuff for partners that want to ship stuff with us from point A, often in an international location, to point B, often in the United States. And there are many, many parties behind the scenes that have stake in this game to be able to move that cargo compliantly from point A to point B. And every single step along the way, traditionally, involves more and more paper being stacked up and passed to the next person, collected to make sure that all the ticks and ties are in place to move stuff around the world. We abstract a lot of that complexity away from our clients so that they don't have to worry about all this logistics mess behind the scenes. We focus on that, and they can focus on building awesome products and selling it to their customers, which is really what they want to do in the first place. So one of the key value props that Flexport offers partners that ship with us is answering this simple question: where is my stuff? It seems like it would be so easy, especially in an age of Amazon, where we can order something on Amazon and just see like a tracking number of exactly where this thing is in its shipment life cycle. That's distinctively not the case in international shipments, particularly when you have all of these different parties, all of these different people with these pieces of paper that they're accumulating and stacking up and creating for this entire journey. It's often really difficult to answer this question. It can take up to a day sometimes to just figure out where your stuff is in the life cycle. And then to kind of cover it in a different angle, I want to cover why trucking really matters to our clients and why we're focused on that here in the Chicago office. This graph represents a really typical shipment for a lot of the partners that we work with. They will produce goods, some sort of product in some origin factory in a country of origin. Then Flexport will help orchestrate a truck to go pick up that stuff at the origin factory and bring it to a port in the origin country, where it will either get on an airplane or onto a ship. And if it gets on an ocean ship, an ocean liner in like a big container, it can take up to 14 days for it to get across the entire, across the ocean. Then it arrives in the country of origin in a destination port, where it goes through customs. We handle all of that for our clients as well. And then we orchestrate another destination trucking leg, which is this final piece here, and it kind of highlighted in green because this is what we're, spoiler alert. This is what we're focused on here in Chicago is destination trucking. Once stuff has gotten to the country of destination, the destination port, can we provide more visibility to our clients than they get today on where their stuff is in that destination trucking leg? That destination trucking leg is the piece that actually matters the most to our clients to understand where their stuff is, to answer that question. Because when something's in the middle of the ocean and it's like has another week until it gets to the destination country, there's not really much that's actionable that customers can do, or shipping partners can do. They know that it's going to get there in a week, and there's not much that they can really do to prepare. But once something has arrived in the country of destination and it is on a truck, it's been loaded onto a truck, and it's en route to the ultimate place where they want to receive those goods and be able to sell them, that's when they really start to care. They want to know, like, down to the hour, if possible, ETAs for when it's going to reach that destination warehouse so that they can start coordinating their own teams. So we've been focusing and building technology around this kind of concept to provide, to kind of contribute to Flexport's overall value prop of where is my stuff, but from the destination trucking piece where it's most critical. So to do that, we've built a suite of software that we call Transmission. And in this presentation, I'm going to cover Transmission Web, which is the product that had this map component that had this performance issue that I wound up addressing. So Transmission Web is built with React. Mapbox.gl is what we use for our map component. We use GraphQL and Rails on our backend. It is a giant Rails monolith. This is the first time that I've worked with Rails. I actually really enjoy it. It's a lot simpler than I thought it would be. And I'm not a backend person. I've done front end for years and years and years before coming to Flexport. And it's allowed me to contribute to backend code a lot faster than I thought I would be able to, which is pretty sweet. This GIF, what you see here, I say GIF. I say GIF. Yeah, I know it's like heresy, but it's in my blood. I say GIF. In this GIF, this is a screen of what a trucking carrier that we partner with might see when they use Transmission Web. It is a suite of software that is used for carriers that partner with Flexport to move Flexport cargo in that destination trucking leg that helps them better manage and organize their fleet of trucks. And they can get down to the truck information on where that truck is and kind of like scrub through time, which is what we're doing here. This is like a flashy feature that customers really like. With GPS information from devices that are plugged into the trucks themselves so that our partners can see, or carriers can see like down to the minute where their trucks are in the route of a delivery at any given time. It helps them manage their systems a lot better, and it also allows Flexport to get that more visibility into that where's my stuff question. So it's kind of like a symbiotic product. It benefits our carriers, but it also benefits Flexport, which is why we invested time and money into building it. Okay, so that's enough about Flexport and setting like kind of like the business case for why we're doing this. And now I'm going to dig into this performance problem that I wound up solving. This was like one of the first tasks that I got at Flexport, so kind of keep that in mind as well. It's challenging, especially working with just like a totally new code base being like 1 month into a job. So the problem was, and the reason that this was a priority was because we were preparing to onboard some larger trucking carriers onto Transmission. Previously, we've been working with carriers that had maybe around 20 to 30 trucks. That's kind of indicative of the trucking industry itself. There are a lot of very, very tiny carriers with that sort of scale of trucks. Whereas if you look at ocean, there's only 8 major ocean carriers. So it's a lot easier to like integrate with and get data from those 8 versus literally hundreds of thousands of trucking carriers, from a mom and pop shop with a couple of trucks up to hundreds and hundreds, maybe even 1,000 trucks on that kind of scale. So we were getting ready to onboard some larger carriers on the order of a couple of hundred, and we'd previously been working with the order of like 20 to 30. We realized that when we were preparing for this and we were doing some testing, that this map component that we had would just turn to complete molasses when we simulated around 100 or so trucks, even like 50 or more. The hover animation, we have a hover animation if you hover over one of these cards. These cards to the left of the map all represent different trucks that are on the map itself, and it scrolls. And then these markers on the map all represent particular trucks in the carrier's fleet. So we simulated a bunch of trucks. That hover animation, where if you hover over one of these cards, a tooltip would appear over the marker itself, take like 3 seconds to render, and map movement was absolutely just molasses slow, like 1 frame per second at some points. So there was clearly a scaling problem that had to do with data, because we hadn't seen this before until we simulated all of these trucks. So it was my job to kind of dig into this and figure out why. So because I was so new and I didn't really have intuition around the code base and around like where these problems might be occurring, I realized that I needed data to kind of drive my efforts. Fortunately, the Chrome Profiler is just absolutely amazing to give you very targeted information around performance problems in applications. I've done some profiling, this like Chrome profiling of pages before, so it was a little bit familiar to me. And for anybody who hasn't used it, it's super easy to use. There's no like add-ons or plugins or anything that you need. It just comes baked into Chrome. You just open up the Dev Tools, go to the Performance tab, click Record, and then make an interaction on your page that you're collecting this data for. And I always suggest to folks who are doing these profiling activities to focus on one interaction at a time. I find that the profiling output itself can be kind of intimidating, even if you know what's kind of going on under the hood. So for example, I decided to focus first on this hover animation, collecting profile information on that, and not muddy the waters with a whole bunch of like map movement stuff as well. It just helped focus the effort even more. So I'm gonna cover both of those interactions and some kind of like root cause analysis and stuff that I went through to debug it with the help of the profiling output, and we'll take a look at some of that too. So here's another GIF of the hover animation that I was talking about. This is the first interaction that I tried to dig into. And you can see that the mouse is hovering over that card. There's kind of this like tactile feel animation of the card itself where it like pops out a little bit with the drop shadow and has this little like green bar. And it's taking like a second and a half-ish to render and also to show its corresponding tooltip on the map. It just wasn't performing as well as we needed for our clients. It wasn't the experience that we wanted to deliver. So this is the profile output that I collected from one single hover animation that I collected from a record. And something immediately popped out to me as bizarre, and it was this repeated pattern here. I was expecting there to just be one block of scripting time in response to this one single hover animation that I did, but instead I was seeing 3. And that seemed really strange. Like, why would I be seeing these 3 repeated blocks that all look exactly identical in response to just one single interaction on the page? And so from this output, I was able to figure out, okay, this card is actually, whoa, something is falling. It's distracting. This thing was called a truck card in our code base. So I decided to take a look at truck card a little bit closer to figure out, what are the event listeners that are responding to hover that are associated with truck card. And this is what one of those truck cards looked like. It kind of like a zoomed in level. Each of these green boxes represents a subcomponent within this entire card composition. So there were 4 subcomponents, each of which kind of was responsible for one piece of the card itself. And on the outermost wrapper of the card, we had an event listener for the on mouse over event, which we were using to do all of this hover animation kind of response. What I was starting to notice when I was digging into this a little bit more in finer grained detail was, as I was hovering over any of these subcomponents within this composition, that on mouse over event handler was triggering again and again and again. Literally every time I would touch one of those green boxes. And that was baffling to me, but that was clearly the repeated pattern that I was seeing there. And I was just confused. I was like, why is this happening? I've used on mouse over before to respond to hover. I feel like this should work. Well, what I found was there's a very distinct difference between on mouse over and on mouse enter that I was not aware of before. On mouse enter and the corresponding on mouse leave events propagate from the element being left to the one being entered instead of ordinary event bubbling that you would expect from events in JavaScript. On mouse over, which is the one that I was using before, events bubble out from subcomponents to the parent components all the way up the DOM until something catches it in an event listener. So even though we had this listener, a single listener on this card component, these on-mouse over events from all of these subcomponents were being captured by that same event listener because they were bubbling up out of the card. That's that event bubbling. I didn't want that. We definitely didn't want that. We didn't need to respond to every single one of those subcomponents being hovered in this particular case. So on-mouse enter seemed like a really clear winner for a way to reduce that repeated pattern that we were seeing in the profiler. So I made a little JS fiddle to sort of show the difference and highlight just to make it a little bit clearer, like the difference between these two. I have 2 boxes on the screen. This top one has an event listener that is subscribed to on mouse over and on mouse out events. Those were the old ones that do that kind of like collection of bubbling behavior. This bottom card has a wrapper on the outside with an event listener that's subscribed to on-mouse enter and on-mouse leave. That's the one that I was proposing that we move to. I actually showed this exact demo to my team just to make it super clear why we were making this change. I find JS Fiddle is a really nice isolated way to demonstrate changes to folks at work. So, and I also have counters at the top here so we can see how many times these things are responding when we're doing this hovering. So as I move throughout this card on the top, you can see that literally every single time I'm touching one of these subcomponents within this card, any of these pieces of text, that counter is incrementing again and again and again. That's exactly the behavior that we were seeing. Now, if I go into this one on the bottom, you'll notice that the counter increments to 1 when I enter that card the first time. And then I can touch any of these subcomponents inside of this card, and that counter is not going to increment again until I leave. And then it increments to 2. That represents leaving the card, and that's the proper way that we wanted to respond to this hover scenario. So in this particular case, on-mouse enter and on-mouse leave were the right event choice for us to subscribe to. And I learned a little bit about the difference that I never knew before. So I hope y'all don't make the same mistake now. Okay, so this is again what the profile output looked like before. And then after implementing this change, it literally just shrunk to one of those pieces of pattern. And it saved about 2 seconds per hover animation, which was awesome. And it looks like this. It's so fast. You can move as fast as you want. It's just smooth like butter. That's what we're looking for. Great. Okay, so now after I fixed that one, I needed to dig into the second interaction that we were trying to optimize for, which was this low FPS during map movement. You can see in this, it's clearly very chuggy. That is my technical term for dropping frames. And it happens when you're moving the mouse, or moving the map, when you zoom into the map, both scenarios. So took another profile recording of moving that map around. And I found the interesting part was actually in the activity panel, which is at the bottom of the profile output. The flame graph itself, like what we were looking at before, those chunks and patterns, did not give me any useful information to figure out what was going on. But in the activity panel, which captures all the functions that are being called during your profile recording, so the profiler can capture all that information, that actually can be super useful to figure out what is causing a long amount of scripting during your interactions. So when I'm looking at this, I want to make sure that I'm focusing on files on functions that originated from code that I actually wrote and that we actually owned ourselves, which in this case was this highlighted blue row, this truckmarker.jsx. Clearly there was some anonymous function that was being invoked that was taking up 6 seconds of scripting time when I was moving the map around. And it appears that per that line number, which is shown here in the source, it appeared that this anonymous function was a call to set state inside of truckmarker.jsx in response to the mapbox.gl render event. And what I found, again, after digging into render a little bit more, was render fires in many, many scenarios. And it is way noisier than the case that we needed to respond to in our marker components themselves. The marker components have these tooltips. And if the tooltip is being shown and somebody moves the map, the tooltip will stay in place and it'll look like it's just flying away from the marker itself. So we needed to subscribe to map movement events, and we were doing that with render to make sure that tooltips are basically hidden whenever the map moves. So that was the use case. That was why we had this subscriber in the first place. We were subscribed to render. You can see, and I found this out from the mapbox.gl documentation, that render does fire in changes in response to changes in position, zoom, pitch, and bearing of the map itself. But it also fires whenever tiles are loaded on the map, whenever styles change, and any changes to GeoJSON source that is loaded onto the map itself. We don't need to respond to those types of events. Really, we just care about map movement so that we can hide those tooltips. So what I found again was there is a much less noisier event that is called move. That when swapped out from render to move, move only fires in this small subset of those render event possibilities. which was exactly what we needed for our use case to hide those tooltips. So I have another small demo. So this is a Mapbox.gl map loaded in JSFiddle. And as you can see, I just loaded the map, and already my render count at the top of the page is 79, which I have event listeners that are subscribed to both render and to move. So I'm just trying to keep track of those to prove that this is going to be a performance improvement. And as I move the map around, you can see that the move count goes up, but the render count also goes up because it responds and fires in the same case, but it's also loading different tiles as I'm moving around the map. And it's often, I was finding that it could be like an order of magnitude of like maybe 2x or 3x the number of events that were being emitted with render versus move. So clearly making that change would be a huge benefit when we just really needed to respond to the map moving itself. So that was great. We made that change, and the frames per second went from maybe like 1 up to maybe 10. So that was an improvement, but there was still a little bit of work that we needed to do to make sure that this map was going to be ready for our partners. And another chunk of the profiler output gave me some insight into maybe something else that could be going wrong. And that was this, I think it's called like the memory panel, where it's showing you like the amount of event listeners that are being added to your page as part of like your app's interactions. And I found that this event listeners count was just spiking as I was moving the map around. And it started around 494 and it went all the way up above 5,000. So this seemed like excessive, and I was confused about why this was happening. But I had a little bit of a clue based on some of the work that I had just previously done. So I had just changed the event that we were subscribed to from render to move. That was done in truckmarker.jsx. We saw that from the activity panel before. Every single truck marker here had one of those event listeners that was subscribed to move. So literally every single time that the map moved, every single marker on the page was responding to the movement via its own event listener. This made perfect sense why we didn't see this as a problem until we added more markers onto the page. Clearly it like shows that this was only a problem that was going to happen with scale. It's a classic n problem, scaling by n problem. So what I realized was these truck markers don't actually need to keep track of this little slice of state to show whether or not its tooltip should be shown, to determine whether or not its tooltip should be shown. That could all be abstracted up into its container component, which is map container. And instead, that map container could just have a single event listener that was managing this piece of state on behalf of all the truck markers, and that piece of state could be passed as a prop down to all the truck markers to turn them off if needed when the map is moving. So that took the n number of listeners that we had before and changed it down to 1. That feels really good as a computer scientist. We love O of 1. We don't love O of n. So with that change, the combination of those two, our map movement improved by 30 frames per second, and it was just buttery smooth. That's why I like the butter emoji there. And this is what it looked like before. I couldn't like fit this into my presentation for some reason. It just like I had to load it in a different tab. But yeah, it's just much smoother. No dropped frames. Well, there are some dropped frames, but like it's good enough for what we were going for at the time. Satisfied our customers' needs. Cool. So the takeaways that I had from this whole experience was, number one, definitely take the time to learn the details of events before you subscribe to them, because they can have very serious implications to the performance of your app if they're noisy. Even if they work for your use case, it's worth trying to investigate and see if there's maybe a less noisy event that you could subscribe to, so you don't get into any of these scenarios. Like I definitely won't with on-mouse over versus on-mouse enter, or with render versus move anymore for these particular cases, but I'm much more sensitive to the events that we subscribe to now just overall in our app. The second one was that data was super helpful. The Chrome Profiler data was very helpful to drive the performance effort that I had, particularly because I was so new to the team. This was like a task that I had during my first month. I was still developing and building intuition for the app itself. Maybe some other folks in the team would have known just, oh yeah, this needs to happen in like truckmarker.jsx, but that was just pretty opaque to me as a new person. So the data was really, really helpful. The profiler, I'm like the profiler guy at work now, which I don't really like because it's still, I find the profiler output to be kind of intimidating. But I'm happy to consult now. I guess I'm like the profiler consultant at work. And then the third one is to know when to stop optimization work, because optimization work can just kind of be a black hole. You can always make something a little bit faster or a little bit better, and it takes a lot of discipline to know when something is good enough and to move on to higher priority tasks. Like if I look back at this result, where our event listeners are only going up to 1,400 instead of 5,000 for like a similarly long duration profile, I feel like it shouldn't be going up like at all. I feel like it should just be constant. I still don't know why that's happening, but we had higher pressing needs on our team that we needed to work on versus figuring out why this is happening in the first place. So we backlogged these items. We had the discipline to do that so that we could move on and work on higher pressing needs for the company. Thank you all. Again, like Flexport has just established an engineering office here in the city. If anybody's interested in learning more about Flexport, please feel free to reach out. Thanks.